thank everyone to be connected today for this event around open science in health. To begin this session part of the day, we welcome Leo Anthony Celi, Research Director and Principal Research Scientist at MIT Laboratory for Computational Physiology. Thank you, Leo, to be connected with us today. If you are ready, you can take the lead and start your talk.
Perfect. So I kind of renamed the talk into Science by Us for all of us. I added that to the original title, and the tagline now is from open science to community science and the role of artificial intelligence. Before I proceed, I wanted to disclose that I don't have any conflict of interest relevant to this presentation, although our group receives research funding from the National Institute of Health and National Science Foundation of the United States and the Ministry of Health and Welfare in South Korea. And I wanted to start with this question before I plunge into discussion of community science. What was wrong with science pre-AI? And the two follow-up questions to that question are, can we fix it with AI and how? And then more importantly, who can fix it? I'd like to start by describing this phenomenon called epistemic injustice. And that's when a knowledge system is unintentionally harming certain populations. The example that I give for epistemic injustice is how we disseminated information about heart attacks by sharing primarily findings that were observed in white men who are having heart attacks. So the description of acute myocardial infarction in textbooks and the trials that have been performed looking at tests and treatments for heart attacks were primarily enrolling white men from rich countries. And one of the unintended consequences of this is the fact then that when women develop heart attacks, their likelihood of having poorer outcomes is higher than if they were a man. And this is because we don't understand fully how heart attacks manifest in women. We don't understand fully what are the best treatments for women because they are disproportionately underrepresented in clinical trials that are being performed. Prior to the pandemic, we worked on this paper where we talked about the myth of generalizability in clinical research and also in machine learning. And we have argued that the findings that we sensationalize in journals, including those from clinical trials, their validity is limited by space and time. So the treatment effects that are reported are influenced by the specifications of the experiments. In clinical trials, I'm referring to the existing clinical practice at the sites and at the time of the trial, which, as we know, does not remain static. There's also the artificiality created by the clinical trial itself. So in a perfect world, what we will do is to repeat clinical trials for every subset of patient, for every clinical context. But of course, we know that that is not feasible. And this is where artificial intelligence might play a role. The other issue that I wanted to remind people is this, what we refer to as the 1090 gap in biomedical research, that highlights that only about 10% of global research funding addresses diseases that account for 90% of the world's health problems. And the research output is concentrated in high-income countries, which produce approximately 80% of global publications, despite representing only 16% of the global population and 10% of global disease burden. And this needs to be fixed. And maybe there is an opportunity now afforded by this powerful technology that will allow us to have a knowledge system that is more inclusive. So let me go back to my question. And another follow-up question would be, how will the creation and validation of knowledge, how will the creation and validation of science how will that be affected by AI? But I think the correct question would be, how will that be affected by how we change the way we think, the way we learn, and the way we work together? Because I really think that AI is a Trojan horse that we have been waiting for that will transform the way we live, the way we learn, the way we collaborate with each other. But how do we educate in a field that is moving so fast? By the time a course is approved and or a syllabus is written, it is already outdated in this field of artificial intelligence. This is why legacy systems for education, knowledge creation, clinical validation, innovation, and regulation will require tectonic paradigms shifts. So the original title of my talk is open science as it relates to the database that we have shared to the research community, and that is the Medical Information Mart for Intensive Care. It is a publicly available database of patients admitted to the intensive care units of the hospital where I work in. And we've de-identified it, and we've also set up data governance around it so that there are requirements before anyone can have access to the data set. And it's been available for 15 years, and I will go over the impact that we think we have contributed to the research community. And again, I wanted to say that we need to move from open science to community science. What we have learned in the last decade is that open science unfolds in a non-neutral space where there are power structures. So the benefit of open science is not equitable. And unless we invest in building communities, data communities, then we may not be able to fully leverage the value of open science. So we coined the term community science. And just briefly, this is what we have gifted the world. So there are several versions of the MIMIC dataset now, and as you could see, the MIMIC 3, which is the version that was released in 2016, has already been cited more than 8,000 times. We have several other databases in the pipeline. We have the EICU, and together, all these open data sets have really pushed the field of machine learning, because now students and investigators from around the world have access to electronic health record data sets. And we receive complaints all the time that students cannot even have access to the data set from the hospital where they are doing their PhD. And just to show you that looking at the number of citations, if we compare MIMIC with the UK Biobank, with the Open Safely data set from the United Kingdom, and against All of Us, which is another data set that is funded by the NIH, MIMIC outperforms all the other data sets. And we think the reason for this is how our group has invested in building the data communities that I will describe to you. And when you standardize that according to the amount of funding that these different data sets have received, then you could really see that for every dollar spent, that we produce more citations with compared to the other data sets. So how do we do this? We are part of a global consortium called MIT Critical Data, where the focus really is to bridge communities, to bring people across generations, across continents, across countries, across disciplines together. Because what we have realized is that the data sets are far too complex for any one group to be able to curate. We need to harness collective effort to understand the data, because the race to build models without understanding the data, as you know, is perfect recipe to build algorithms that will perpetuate the problems that we're seeing now. Some of the activities that we organize to invest in this social capital include what we refer to as real-world evaluation of language models. So this is how we bridge communities. And we're actually going to organize one of these in Paris at Oaken on July 3rd. So I would love to see some of you attending this event. And the idea here is we give the language models to the actual users and have them evaluate this according to specific tasks. So we've coined the acronym LTARC, and LTARC stands for local, in fact, hyperlocal. We think that the evaluation of language models should occur in every county, in every health system, in every university. They have to be task specific. The problem now is that people conflate benchmarks with evaluation. Benchmarks are not evaluation. They are too high level. They're not task specific enough to tell us how a generative AI tool will perform answering specific questions. They also have to be agile. The evaluation has to change over time because our requirements would change over time. They have to be reflective and reflexive so that we are able to incorporate any comments, any criticisms, any suggestions on how to improve these language models. And most importantly, these evaluations have to be community operated and they have to be continuous too. Just because we have validated a language model for depression this year does not mean that the same language model would still be useful for patients and individuals with depression the following year. As part of these events, we also organize what we refer to as HASTE policy camps. HASTE stands for Health AI Systems Thinking for Community, and this is where we divide the participants into small teams, and each team would consist of members across generations from high school all the way to professors to CEOs. And then we also make sure that they represent different disciplines. And then what we do is we give them papers on algorithms for healthcare published in the last couple of years. And what we request them to conduct is to imagine the worst possible scenarios or the unintended consequences of this algorithm, especially if they get in the hands of people who only want to make profits. And then we ask the teams to come up with guardrails, not necessarily policies, but also incentive structures so that we avoid the harm that we were able to identify as a result of these algorithms. We have been looking at what is the impact of these events that we organize. Again, I wanted to point out that opening the data is not enough. You need to invest in truly creating an ecosystem that will allow communities to learn from each other, to learn about the data, and to build models. And one of the projects that we did was to look at the publication footprint of people who attend our events. So in this particular project, we compared people who attended datathons with those who were already publishing on the topic. We went back 3 years before and then 3 years after. And what we found is that 3 years before, the people who were already publishing in the topic had more publications and citations. But 3 years after, the other group actually caught up and even surpassed the control group in terms of publications and citations. But more importantly, what we found is that the research network of those who attend these events are much more diverse than the ones who are traditional investigators. So people always ask, what do we need to teach our students about AI? And what we think is necessary is not just teaching them about the tools. The tools are going to change over time. What's more important is that we make sure that we preserve our critical thinking. AI is giving us the temptation to do shortcuts. We are probably a year away when we could dump a whole data set like Mimic into a large language model or a vision language model, and then we ask it to write a full paper. So it will be a full stack researcher that will produce an entire research manuscript from beginning until end. Therefore, if we're not careful, we will be swimming in research that is manufactured by AI with little human input. And we really need to think more thoughtfully and deliberately so that we could prevent this disaster. So the way to do it is to really double down on teaching what we refer to as critical thinking. Some people refer to this as systems thinking. In medical education, this is referred to as health system science. We also think that it's very important to teach epistemic humility. So epistemic humility is humility that arises because of your understanding that your knowledge is a product of your experiences and your exposure to information. And for that reason, since no one can have all the experiences in the world, then everyone will have an incomplete understanding of the truth. And for that reason, the natural effect would be to seek to think with people who don't think like you. I love the saying, when everyone is thinking alike, no one is truly thinking. Because if someone had been thinking, that person would have pointed out that, hey, our blind spots are overlapping. We need more people here who could look at the problem from different lenses. So I have been very critical of labs where all the students are coming from the same department and the principal investigator is a professor from that department. I think that that is recipe for groupthink. And if that is the case, well, that laboratory should at least be having dialogues and conversations with labs from other schools and departments. We also encourage reflection. We need to always ask ourselves, what's motivating our science? Is it academic promotion? Is it publication citations? Is it professional identity? And there's nothing wrong with this motivation. What's important is that we recognize that these are the main driving force that shapes the science that we create. And reflection only works when you're doing it amongst those who don't think like you, and also when there is psychological safety to challenge each other. Knowledge or understanding of truth is purely based on experiences and observations. There is no such thing as ground truth. How we see, how we perceive things objectifies, or more aptly, subjectifies those things. This brings to mind Schrodinger's cat. And the question is the cat dead or alive inside the box where it is holed up with a cyanide poison that can be activated by an atom depending on the quantum state. And at any one point, the cat is neither dead or alive. It depends on the quantum state of that atom. And the reason why I brought Schrodinger's cat is to really emphasize that without plurality of perspectives and lived experiences, there is no science. Groupthink is the enemy of knowledge. In the movie Conclave, Cardinal Lawrence, the dean of the conclave, said, "Certainty is the enemy of unity. Certainty is also the enemy of science. Hubris is the enemy of the good. It's not perfection." This is why we need to start with epistemic humility. Our mental model of the world is imperfect, and our data sets and algorithms more imperfect still. And I'm going to end this presentation so that we have a few minutes for question and answer to talk about why we need to stop building models. We need to stop building models because we are already drowning in models. We need to start designing human AI systems. The field of AI, or IA, as you refer to in France, has advanced, but without consideration of how human frailties might dampen its value. Integrating human virtues such as curiosity, empathy, and humility into AI systems is essential for ethical deployment. Hubris in AI systems, characterized by excessive confidence and refusal to admit uncertainty, undermines trust and safety, particularly in medical applications where errors can have disastrous consequences. Curiosity should be embedded in AI design as an intrinsic motivation for exploration, while humility allows systems to recognize their limitations and defer to human judgment when necessary. A synergy between curiosity and humility is proposed, suggesting that these traits can complement each other to enhance learning and adaptability in AI systems. And with that, I'm happy to answer any questions if you have some. I believe we have 2 minutes.
Thank you so much for this presentation. Yeah, so we have some question here.
So thank you for your presentation. I do have a question because with your presentation, I understand that like the critic spirit of thinking needs also some other methodologies, like maybe some qualitative technologies, methodologies. So time for discussion, time for interaction, for iteration also with the different people or communities. How do you convince your sponsor or people who are expecting some result and quick result, especially in IA? Do you have also some strategies to allocate some budget for that? So what are your, I would say, what do you advise about that?
Yes, so this expectation of a quick turnaround time, that you will have some return on investment, and then the focus on KPIs, I think that's all going to harm us. And as you mentioned, there has to be more deliberation. It's not just all quantitative analysis. And I think our society has made us biased against qualitative studies. We think that qualitative science is less scientific. Now we're saying that it's actually more important because sometimes you hide the problems, the pitfalls within those quantitative analysis where you lose a lot of information, right? I'm not a big fan, for example, of surveys where there are right or wrong answers. In real life, there are no right or wrong answers. There's always contextual. And I think this preoccupation, this obsession with coming up with statistical estimates, I think is in the long run, that's going to be our downfall. This estimates, one, they don't really translate to patient outcomes. Like a model could have perfect accuracy. And what we found in the past is as soon as you prospectively validate that, it doesn't deliver. It doesn't improve the overall accuracy of radiologists. We have several papers from last year that debunk the myth that overall this AI will improve the performance, especially those who are more novice in decision making. We did not see that to be the case. And I think it's because we are really launching this without performing the qualitative studies, the human factor studies that need to accompany them. So I'm urging people to really reflect that where we are heading, our strategies may not be the best way of moving forward in this field.
Thank you for your answer. Any other question?
Hi, thank you. I really liked your last take on the human AI part and the collaboration. So I wanted to hear your thoughts on how do we not transform humans into a role where they're basically just check on the AI and have to constantly verify instead of now as we move with more agency.
Yes, this is a very rich discussion. I could spend hours talking about this, but somehow we need to focus on the decision making. We need to see proof of critical thinking when we publish our work. So I keep saying that the scientific paper of the future of today actually should not be introduction, methods, results, discussion. That can be generated by AI. It should be a digital trail of what decisions were made, how did the question come about, what are the iterations in the study design? Because we need to future-proof this decision-making. We need to future-proof our behavior, good research behavior, and rather than future-proofing the findings, the p-values or the AUC. So I think there are ways of making sure that we preserve our faculty, our agency, our cognitive abilities. But it will require a completely different design for how we educate, how we perform research. And I would like to engage people to think more about this. So if you were to start with a clean slate, how would education look like? How would research look like? How would scientific publication look like? These are the activities that we organize. So I'm hoping that I see some of you. One, there's the summer school that is hosted and organized by this group too. I will be there as well on June 30th and July 1st. And as I said, we're also organizing a separate event in partnership with universities as well as with industry in France, who I must say is at the forefront of AI research with 3 of the biggest companies originating from France. So I'm looking forward to my trip in Paris next month.
Thank you.